In this talk, I'm going to be showing you why and how we can build AI copilots for software platforms. I'm going to be talking about one of the AI copilots that I built, which is Foil.io. So to get started, I'm going to give you a demo of Foil.io and show you how it can help you debug and operate your software. So this is the Hello World service that I'm building and operating. It's a very simple service. Every time we access the page, we get a different greeting. And this greeting is generated by AI, and we're using AI because why wouldn't you use AI to say hello? And so you can see that everything in production is nice and healthy. Every time we access the page, we get a different greeting. But let's check our staging instance. Unfortunately, it looks like for our staging instance, we're getting an error, no unhealthy upstream. So to debug that, I'm going to use Foil. And to get started, I go over to VS Code and I create a new document, which is a markdown document, and we'll call it fixstaging.md. And since I'm using an extension for VS Code called RunMe, when I open up this markdown document, it opens up as a VS Code notebook, so I can add markdown cells and code cells. And so this markdown cell will also be an artifact, which I can use as my postmortem for this issue. So to get started, I'm just going to start typing what issue I want to fix. So I'm going to say fix staging instance of Rube. Why are we getting no healthy upstream error? And so one thing you'll notice is that as soon as I start typing, I start getting these Go cells, which are cells. In this case, it's a code cell with lightly grayed out text. And this Go cell is the AI Foil suggesting the commands that I should run in order to accomplish my intent. So in this case, I've described the problem of having an error, no healthy upstream error, and it's giving me a command to fetch the logs because I probably want to look at the logs to see if any errors are occurring. So this experience should be very familiar to anybody who's used any of the coding copilots like continue.dev or GitHub Copilot. This experience is very much inspired by ghost text from those experiences. And so one thing you'll notice is that this logging query indicates some knowledge and awareness of my infrastructure. So we can see that this query includes clauses to filter down by the logs for Kubernetes containers because I'm running on Kubernetes. And it also knows the label schema for my pods. And so what's happened is Foil has learned about my infrastructure. So it knows that I'm running on Kubernetes and it knows how I'm labeling pods. And it's learned that from past instances of commands I've run. And this is super important because everybody's platforms and infrastructure is different. So unless the AI is able to learn about your infrastructure, it's not going to be very helpful. So let's go ahead and run this command. And so this is one of the nice things about RunMe is that we can run we can run commands directly from the notebook. And so we didn't get any logs, indicating that there's no error in our logs. And so you'll notice is that as soon as the command completed, Foil suggested another Go cell. And this Go cell is the result of Foil analyzing the output of the previous step and telling me what I should do next. So in this case, since there are no errors in the logs, it's suggesting that we should check the services and the pods. So let's go ahead and do that. So let's get the pods. And so what we can see is that we have an error in the invalid image name. And we can see that once again, we're getting another Go cell suggested by Foil. And so in this case, what this Go cell is, it's a markdown cell in which Foil has analyzed the output of the previous command and is telling us what we should do next. So in this case, it's telling us that we're getting a no healthy upstream error. And we're getting this because the pod has an error of invalid image name, and that this typically indicates a problem with the image specified in the pod. And so it's telling us to get the deployment. And so I'm going to give it a little bit of a nudge and say, so it was telling us to get to the deployment, but since I want to just check the image, I've given it a little nudge and told it to just get the image name from the deployment, and that's just going to make it a little bit easier to narrow down what's going on. And so you can see that it helpfully gave me the command syntax to use JSON path. And so I find this to be very valuable because even though I know JSON path syntax exists, I always struggle to remember the correct syntax. But by using the AI, I can actually get that command without having to struggle with the syntax. And so here it's pulled out the image name. And we can see that the image name has a couple bugs in it. First, we're using the @ symbol to separate the image tag from the repository, and that's incorrect. It should be the colon symbol. And it should also be v1, not v.1. And if we look, Foil has helpfully figured this out and is suggesting to us the correct command. So let's go ahead and execute that command to fix the image. So great. Now let's ask it to restart the pods. So we'll restart the deployment. And now we're going to check that the pods are running correctly. And yeah, it looks like we're back up and running. So let's check that. And great, our staging service is nice and healthy again. And so what you saw is how Foil walked me through debugging that staging, figuring out what the problems were, and then figuring out how to correct them. So let's go ahead and check the dev instance. So we can see that in the dev instance, we're also getting the no healthy upstream error. So let's go ahead and debug that the exact same way using foil.io. So we're going to go over to back to VS Code, and we're going to create a new file. We're going to say fixdev.md, and we're going to start adding a markdown cell. So Foil is giving me the same exact command as before, which is to check the logs. That makes sense because we've gotten the exact same error, and checking the logs is always a good place to start. So let's go ahead and run that command and look at the logs. So in this case, though, we actually have an error in the logs. So it looks like we have a different problem. And so we can see that in this case, we get a command from Foil, which is a Go cell, which is analyzing the output of that cell logs, and it is telling us what this error means. So it's telling us that the error indicates that the API key stored in Google Cloud Secret Manager can't be accessed due to insufficient permissions. So remember, our service is using OpenAI to generate a greeting. To do that, we need an API key. That API key is stored in Google Cloud Secret Manager. And to fix this, we should verify the permissions of the service account being used by the Kubernetes deployment. And here are the steps to follow. So it's telling us that the first thing we should do is to check the service account so that we can identify what GCP service account we're using. So let's go ahead and run that command. So it's given us the Kubernetes service account. It looks like it's actually using the wrong service account in this case. It looks like it's using the default service account. So let's go ahead and fix that and get the output for the Rube service account. And so one of the things you can see is that, again, when Foil makes a mistake, because of the experience we've created, it's very easy to give it a nudge to get it back onto the correct path. So here, it's now analyzed that output, and it's telling us that to ensure that we have the appropriate permissions, we need to check the GCP service account that's associated with this. And that service account is the Rube demo foil-dev service account. So Foil has analyzed the output of our previous command and used that to figure out what to do next. And so it's telling us to get the IAM policy for that service account. So let's go ahead and do that. And so we can see that for that service account, the only binding that we have is for the workload identity user. So Foil has analyzed the output, and it's telling us that based on the IAM policy bindings we have insufficient privileges. And so what we need to do is we need to add the necessary IAM roles. And in particular, we need to add the secret accessor roles. And so in this case, it's giving us a Google Cloud command CLI command that we can run to add that policy binding. But we don't want to use Google Cloud, the CLI, because we're actually using Terraform to manage our permissions. So we're going to give it a little bit of a nudge, and we're going to say use Terraform to add the permissions. And when I did that, now it's given us a Terraform resource that we can add to our Terraform policy. And then it's giving us the Terraform command to apply that. So let's go ahead and run that. So it looks like that successfully occurred. So now let's tell it, restart the pods. Great, so we've restarted the pods. And now let's check the pods. So it looks like we have some new pods that are coming up and they don't look to be crash looping. Let's go back over there and let's check. And fantastic, the dev instance is back up and running and it's nice and healthy. So hopefully that demo gave you a sense of how Foil can diagnose different problems and walk you through the bugs as they occur. So now let's talk about why we need to build AI copilots to help us operate our software platforms, as well as how we go about doing that. So let's start by talking about why we should use AI. And I think it's easy to get caught up in all the hype these days with AI and think that, hey, we should just sprinkle some AI on whatever problems we have. So let's start by talking about what it means to be a software-enabled business. A software-enabled business is fairly simple. We write software, then we ship software, and then we make money. And today, writing software has never been easier, especially with AI. We have a ton of software products like GitHub Copilot that make writing software very easy. And in my case, I was able to use GitHub Copilot to write most of the code for Hello World. But when it comes to shipping software, it's still quite painful. And today, largely what we do is we give application developers a whole bunch of tools, such as the CNCF landscape, and then we sort of say, have fun deploying and operating your service or application in production. And we can see that if we take a look at what it took to get this Hello World service that I built into production. So I wrote some Go code, and most of that was actually written by OpenAI. And then I built a container and pushed that to Artifact Registry. And then since I was deploying this on Kubernetes, I had to create a Kubernetes deployment resource. And since I needed to access a secret in Secret Manager, I had to create a service account and set up IAM policies as we saw in the demo. And I then had to give them the permissions to be able to access the secret in Secret Manager. And then since I wanted to expose this service to the world, I had to go and create all these resources like a service, an HTTP route, and an IP address in order to expose this service to the world. So quite a lot of effort is involved in deploying this service and then keeping it up and running. And I don't think we can fix this by building more tools, because we've been building tools for almost 20 years now, and the problem of operating our software has only gotten worse. So what I think we need to do is we need to make our existing tools more accessible and make it easier for application developers to use the tools and learn the tools they need to use in order to get their application into production. I think the way that we solve this problem is by using playbooks to simplify shipping software. Because if you have a playbook, then you can just blindly follow that playbook in order to accomplish the task you're trying to achieve. As an example, if I had a playbook for deploying this Hello World service, then I could just copy step 1, which might be co-build, and then step 2, which was kube control apply, and then step 3, the Terraform apply to create all the necessary GCP resources. The problem is we can't keep up with writing the playbooks to deal with all of the complexity that we have these days. There's just too much combinatorial complexity as a result of all of the tools in the space that we can possibly use. And as a result of this, there's too much branching. So as an example, what we saw in the demo is in 2 different cases, we had the same exact error, no healthy upstream. And then we started off in both cases by looking at the logs and searching for errors in the logs. But based on the output of that step, whether there was errors or not, we went down two different paths. And at every step in this debugging process, we can get further branching. So we don't have a very simple linear flow of information. And this makes it very difficult to write a playbook as well as to read the playbook. And this is a problem that I think Gen AI is ripe to solve, because I think Gen AI can write our playbooks for us. But not only can it write our playbooks for us, it can generate those playbooks just in time for us so that the playbook that we're reading is tailored to the particular problem or task that we're trying to achieve. And the insight really here is that achieving some intent, like debugging a problem, is really a sequence prediction problem. So if we have an intent, we can use an LLM to predict what is the command we should run to achieve that intent. We can then execute that command to get some output, and we can then have the LLM analyze that output and tell us what we should do next. And by iteratively repeating this process, we can generate a playbook that walks us through accomplishing the specific intent or problem that we're trying to solve. So in order to do this, all we need is data that we can use to train the model. And so to do that, what we've done with Foil is we've created an IDE for operations, because as a side effect of trying to get things done in this IDE using run me and VS Code, we can actually log all of the data we need in order to train the AI. So if we look at the markdown cell where you're describing the task that you're trying to accomplish, that is your intent. If we then look at the code cell that comes next, that is the command that you're trying to run. And finally, after we execute that cell, we capture the output of that command. And so we're getting that sequence of intent, command, and output, which we can then use to train the model. And one of the things that's really important with this process is we don't want just data, we want to get really good data. And the way that we get really good data is by collecting human feedback, which can tell us when the model is making a mistake, and we can use that to improve the AI so that it can actually learn about your infrastructure and platforms. And you saw that at work in the demo. So what happens is the AI suggests a command as indicated by this go cell. You then accept that command. And if that command is wrong, you edit that cell to fix the command and give it the correct command. So as an example, here we're changing the command from using the CLI to using Terraform. And so this provides a very strong signal to the AI that this is an example of an intent where we should improve and retrain the AI so it gets better. And finally, what we want to do is we want to create a data flywheel. And with this data flywheel, the more data we have, the more we can improve the AI. And as the AI gets better, hopefully we drive increased usage of the AI Copilot because users are getting more value out of it. And this in turn leads to more data, which we can use to further improve the AI, creating a flywheel. It's early days of Foil, but I find that it saves me a huge amount of work, and I estimate that it saves me about 20-40 minutes per day. And this is based on the number of suggestions that I accept each day. And so what you can see in the bottom is the number of suggestions that Foil makes each day that I accept. And right now that's in the ballpark of 20 to 60 suggestions per day. So finally, I need your help. I'd love it if you would check out foil.io and try it out and provide feedback. You can give me feedback on GitHub, opening an issue or a discussion. You can find me at Blue Sky. It's jeremy.louis.us, or you can email me at jeremy@louis.us. Thank you very much and have a nice day.